Alright, we're going to go ahead and review factoring complex quadratics. So, a quick reminder, a complex quadratic, a quadratic is ax squared plus bx plus c. A simple quadratic is when the value of a, so the coefficient of x squared, is 1. So like 1x squared plus 6x plus 5, for example. This would be a simple quadratic. Something like we see here, 2x squared plus 13x plus 21. This is considered a complex quadratic because the value of a is not 1. Okay, and so when we have a complex quadratic where the value of a is not positive 1, we need to look for two things. The first thing we look for is there a GCF? And so a GCF is a greatest common factor. And so that's when you look at all three terms and you ask yourself, are all three of these terms divisible by something? Or share a factor, if you will. So, for example, this one is divisible by 2. 13 is not divisible by 2. And 21 is also not divisible by 2. So 2 cannot be a common factor. This one has x squared. This one has an x, but this one does not have an x. So they don't all share an x. So then, once we figure out that there isn't a GCF, we go straight into doing the box using the box method. So we're going to factor using the box method. There are other ways of doing this, but they're just not as reliable as the box method. The box method is reliable. It will get you the right answer every time and in about the same amount of time. Okay? So let's go ahead and let's do the box method. So considering the fact that we are going from this and we need to factor it into two binomials, that means that these values are going to go inside the box. Alright, so first term still goes in the first box. Last term still goes in the last box. And then the t-chart is the value of a times c. So the value of a is 2, the value of c is 21. So 2 times 21 would be 42. Alright, so we're going to go ahead and write down all the factors of 42. So I'm going to start with 1 and 42. I'm going to go with 2 and 21, which are two things I multiplied together to get 42. And then I think I just checked in my calculator, 3 times 14 is 42. I think 42 is divisible by 6, and 6 and 7 are also 42. So I'm still looking in this list for the two things that combine to give me a positive 13x. So the process is all the same. The one thing you have to watch out for is this a times c is what goes in the t-chart. Okay? So 1 plus 42 is 43. 42 minus 1 is 41. 21 plus 2 is 23. 21 minus 2 is 19. 14 plus 3 is 17. 14 minus 3 is 11. 7 plus 6 is 13. Alright, if they are both positive. So positive 6x plus 7x goes in the two boxes. Now GCFs, these both share an x, so I'm going to factor out an x. These both share, so 6 is 1 times 6 and 2 times 3. 21 is not divisible by 1, not divisible by 6, not divisible by 2, but it is divisible by 3. So I'm going to factor out a 3. What do these two boxes share? They definitely both share an x. However, they're also both divisible by 2. Quick check, 2x times x is 2x squared. 2x times 3 is 6x, so we're good. What do these two boxes share? So 7 is 1 times 7, and 21 is divisible by 1. 21 is also divisible by 7. We want the largest one, which is 7. So this factors into x plus 3 times the quantity 2x plus 7. And so we're going to look for this. I'm going to look for x plus 3. See it here. And I see it nowhere else. So just verify 2x plus 7. So the answer is, in fact, A. Okay, that had a lot of review in it. The next one's going to go a little bit more quickly. So which of the following is the completely factored version of the polynomial? So as a reminder, the first thing that we're going to do is we're going to look and see, do all three of these terms share a GCF? Okay, and so the first thing that I see is all of them actually have an x. So at minimum, I'm going to need to factor out an x. Okay, so I see that 6, 14, and 12, they're all even. So at minimum, I can divide all of these by a 2. So let's go ahead and do that to start. It's okay if you see the bigger one, that's what you want. But I'm going to just factor out a 2x to start. So I'm going to reduce. So 6 divided by 2 is 3. Now some of you might not know how to do this. So x to the third is x times x times x. So for example, if this was 2 to the third, it would be 2 times 2 times 2, right? So x to the third is x times x times x. And so every time we see something over itself or something divided by itself, that's 1. So x to the third divided by x is actually x squared. So it reduces the power by 1. 14 divided by 2 is 7. X squared divided by x. So x squared is x times x. Anything divided by itself is 1, and we're left with just an x. 12 divided by 2 is 6, and x divided by x is 1. Okay? So then let's take a look and see. 3 is divisible by 3 and 1. 7 is not divisible by 3. 6 is. So we're actually done. And so we've factored out the 2x, which you see in all 4 of these answer choices. Okay? So now, because this is a complex quadratic, I have to use the box method. So here we go. First term, first box. Last term goes in the last box. And then A times C goes in the t-chart. So A is 3, C is negative 6. So that'll be 3 times negative 6, which is negative 18. Write down all the factors of negative 18. Oh, yeah, 3 and 6. And I think that's it. Looking for the two things that combine to give us a positive 7x. So 18 plus 1 is 19. 18 minus 1 is 17. 9 plus 2 is 11. 9 minus 2 is 7. So it needs to be a positive, so it would be a positive 9x minus 2x is a positive 7x, and negative 2 times positive 9 is a negative 18. So negative 2x goes in one box, positive 9x goes in the other. These both share an x, and they're also both divisible by 3. These both share a 2. I'm going to factor out the negative. These two boxes are both divisible by an x. They don't share anything else. quick check, x times 3x is 3x squared, x times negative 2 is negative 2x. These two boxes, they're both divisible by 1, both divisible by 3, and that's it. Quick check, 3 times 3x is 9x, 3 times negative 2 is negative 6. So this factors in a 2x times the quantity 3x minus 2 times the quantity x plus 3. So I'm going to look for 3x minus 2 first, which is right here. Verify x plus 3, and we've got our answer.